5:45 a.m. Bus leaves tomorrow. No, 5:45. The bus wheels on the bus will go round and round, round and round, round and round. The wheels of the bus will go round and round with a bunch of gymnasts on. All right, here we go. Whoa. Copy of an angle. That's kind of in the way. Here we go. All right, here's a function. Now you got to concentrate on calc instead of alarms in the morning. Here's a function. There'll be two questions like this. Where does the instantaneous rate of change equal the average rate of change? What the heck am I talking about here? The mean value theorem. The average rate of change is set equal to the instantaneous rate of change of the function. So, what's the average rate of change of this function? Well, f of b minus f of a over b minus a is your average rate of change. Okay? So if you stick in the 4, you get 64 minus 24, which is 40, minus, stick in the 2, 8 minus 12 is negative 4, over 4 minus 2, which is 44 over 2, which is 22. Okay? Then you set the first derivative of the function, which is 3x squared plus 6 equal to 22. Subtract 6. 3x squared equals 16. Divide by 3. X squared equals 16 thirds, and then take the square root of that. And that's where it would be equal. Now, did this question work out perfectly to beautiful numbers? No. What is all of my AP tests always, always, always? They are always multiple choice. So an answer will be there for you. Okay? So there will be two questions like this. Okay? They'll be similar, but not the same. Okay? Where you set, it's basically the mean value theorem. You set the first derivative of the function equal to the average rate of change, f of b minus f of a over b minus a. Now this one is what's up with the mean value theorem? How many values of x satisfy the mean value theorem? Okay? Parker, how many do you think would do?
2, 1.
Andrew, what do you think?
1.
1? I'm thinking your first guess was better. Okay. What did we talk about? It was the average rate of change equaling the instantaneous rate of change. Our average rate of change is right here, right? Okay. So our average rate of change is, we go over 1, 2, 3, 4, 5, and down 1. So it is negative 1/5 is our average rate of change. Where along here would we have a slope of negative 1/5? How many times do you think we'd have a slope of negative 1/5? About approximately. I think 2, about right there, it might have a slope of negative 1/5. And about right there, it might have a slope of negative 1/5. Okay? Because these lines, the tangent lines should basically be parallel to that line. So this is where the instantaneous rate of change is equal to the average rate of change, mean value theorem. So this answer would be 2. This one? Oh! Oh my goodness. It was 3. It was 3. Because yes, because there would be a slope of negative 1/5 right there too, one place. Good job, Dylan. Way to prove your teacher wrong. All right. This one we had just in a different context in the chapter. Where is the second derivative less than the first derivative, which is less than the function? Well, what is the second derivative? That's concavity, right? So Concavity is probably what? Negative. It's probably concave down because it's a negative second derivative. Okay, negative concavity, concave down. So I want it concave down, hopefully, where if this is 0 and this is positive. Is there a place where it's concave down, my slope is 0, and my graph of my function is positive? C. C is where that all happens. Okay? See how that? So we've done these, but this is just a little bit of a different context that you have to wrap your brains around. Okay? Okay. What does this mean? What in the heck does that mean? That's a second derivative. Second derivative is greater than 0, so that means the second derivative is positive, so it is concave up. So where is it concave up and the slope is 0? A. A. What would you call B? It's an inflection point. Way to be on the balls, are you? All right. Where is this function decreasing? Now this is a question like what you've seen on Khan Academy. Where is this function decreasing? What do? First derivative. So the first derivative is simply x minus 6. So 6 is where it changes from increasing to decreasing. So then we test 7 into this. Well, we could test 7 right here. So if it's positive slope here, it is increasing. If we test a 5 in here, or even a 0, whatever, that makes this negative, it would be decreasing slope. So it would be from negative infinity to 6. Okay. What would 6 be? A min or a max? It'd be a minimum because as you're coming in, you're going down. As you're leaving, you're going up. So it'd be a minimum. Okay, good job. How many, if this is our first derivative, you have to, on this test, make sure that you see that some graphs are the first derivative, some graphs are the regular function. Okay, if this was a regular function, okay, we could see mins and maxes. There's one min and one max, but this is the first derivative. So how can we tell how many mins and maxes there are? Wherever it crosses the x-axis is a min or a max. There are 3 mins and maxes there. Okay, 3. This, it is going from negative to positive. So this would be a min, max, min. Okay. Okay. Find the absolute max of this. This is just like Khan Academy. Okay, this is just like Khan Academy. So the first derivative equals what? 3x squared plus 12x. Set it equals 0. 3x comes out. X plus 4 is here. X equals 0. X equals negative 4. So, does negative 4 even matter? No, it doesn't. Only 0, negative 1, and 3 matter. Negative 1, 0, and 3. All right. So if we put in, and then I'm going to put them into the original function to find the absolute max and min. So if we put in negative 1 here, I get negative 1 plus 6, which is 5, plus 4, which is 19. If I put in a 0, I get 14. If I put in a 3, I get 27 plus 54, which is 81, right? Plus 14, which is 95. Well, there's your absolute min. There's your absolute max. Okay? And it depends how it says it. If it says find the absolute min, that's 14. find the absolute max, it's 95. Or if it says find where the absolute min occurs, that's 0. Find where the absolute max occurs is 3. Okay? You got to read the question, what it's asking for. This one, I had to rack my brain a little bit this morning when I was doing this. Where are the critical numbers and the poi of this function if the first derivative is shown? Okay. Where are the critical numbers and the poi of this? How many critical numbers do you see? One there, one there. Okay. And then the point of inflection happens where, okay, this is the first derivative. It's increasing here, it's decreasing here. So if we would graph the second derivative, what would happen there? It would be crossing the x-axis, right? Here, because if you take the derivative of this, it's an increasing function, decreasing function. So this is where it would be crossing the x-axis because the first derivative of this is the slope and so on. So, and here it would go from decreasing to increasing. Yep. Okay. So this is our first derivative. So when our first derivative is increasing, that means our second derivative is positive. Where our first derivative is decreasing, that means our second derivative is negative. Okay? And so then we would cross the x-axis there, cross the x-axis there. So these 2 points would be points of inflection. All right. Where is this function concave up and where is it concave down if this is the second derivative shown? Now this is super easy. Where is it concave up? From where to where? Negative infinity to -2 in union with 0 to 2. Where is it concave down? -2 to 0 in union with 2 to infinity. Okay? So that's concavity. Where is this increasing, decreasing, concave up, concave down? Okay, I want to know all of it for this one. So, what do we do first? First derivative of this equals 40x to the third minus 5x to the fourth. Set the first derivative equals 0. Factor out 5x to the third. We get 8x squared minus, 8x minus 8 minus x. Thank you for setting me straight. 8 minus x. So x equals 0, x equals 8. Okay? So on our number line, we got a 0, we got an 8. So if we set, let's grab 4 here. So if we set 4 in here, we get a positive here and a positive here. So it's positive here. If we grab 10, we got a positive here and a negative here, so it's negative here. If we grab like negative 10, makes this negative and this positive, but negative times a positive is a negative. Okay? So it's increasing. I'll just write it up by the word. It's increasing from 0 to 8, and it's decreasing from negative infinity to 0 and from 8 to infinity. Okay. Concave up, concave down, what do I do? Second derivative. So it's 120x squared minus 20x to the third. factor out 20x squared, and we get 6 minus x. So x equals 0, x equals 6. So if I grab a 3, positive, 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 so it's positive here. If I grab a 10, positive, negative makes it negative. If I grab a negative 10, it's positive here. So it's concave up, and then it flattens out, and then goes concave up again, or it's concave up, and then concave up again. So it kind of wiggles like this, but it never goes concave down. Oh, actually, it's probably this. Something like that. Something like that. So it's concave up from negative infinity to 0, and then from 0 to 6, it's concave down from 6 to infinity. Okay? So what's happening at 0, 1, 2, and 3, given this information? What does the 3 tell us? It's increasing. What does the negative 2 tell us? Concave down. What's happening here? It's either a min or a max, because this is a critical number, and it's concave down. So if it's concave down, this would have to be a max. Okay, what's happening here? Decreasing. And what do we know about the concavity? Point of inflection. What's happening here? It's still decreasing, and it's concave up. Okay, you'll have to be able to see that type of thing. All right, here we go into optimization. A piece of cardboard is 10 by 10. It's going to be folded into a box with a lid. Okay, with a lid are harder than without a lid. Okay, what dimension of the box gives us a maximum volume, and what is that maximum volume? Okay, so we're going to cut away a square here so we can fold it up. Cut away a square here so we can fold it up. Here we'll cut away a square. Okay, so then we're going to fold this up here. So obviously we'll cut away a square here. And this will be the base. And then once this is folded up, we'll fold this over, so we really don't need any of this. We're not going to add extra flaps to it. We're just going to have a single layer the whole time. So whatever this is, let's call this X. Its lid will be the same amount, X. And this is Y. And this is Y. Okay? So actually, let's not make it X. Let's make these little things X, because we're going to cut little squares away. So if this whole thing is 10 inches, I've got X here and X here. So this whole thing is 10 inches minus 2X. Okay, because we take out X there and X there, and there's two parts that are like that, so we're going to divide by 2. So each of those parts are 5 minus X. This is going to be 5 minus X, and this is going to be 5 minus X. Because we add them together, X plus 5 minus X is 5, plus X is 5 plus X, or plus X, plus 5 minus X is 10. Okay? So if this is 10 inches on this side, and I don't think I need to mess with Y's. This is 10 inches on this side. I'm cutting off X here and X here. So this dimension would be 10 minus 2X. So this would be 10 minus 2X. Okay. So the volume of your box is going to be x times 5 minus x times 10 minus 2x. So let's multiply that through. So 5 minus 5x minus x squared times 10 minus 2x is 50x plus minus 10x squared minus another 10x squared plus 2x cubed. So your volume is 2x cubed minus 20x squared plus 50x. How do I find the maximum of my volume? Take the first derivative, which is 6x squared minus 40x plus 50. Okay? If I take a 2 out, I get 3x squared minus 20x plus 25. So if I do the math, 3x squared, outers is minus 15x, inners is minus 5x, which makes minus 20x plus 25. So x would equal 3/5 or 5/3 here. 5/3. And x would equal 5. Now if we make x 5, what happens to this side? It makes it 0. I can't have a side of 0. So that's gone. So x must equal 5/3. So if I get x equal to 5/3, and I want to find my volume, I just stick 5/3 times 5 minus 5/3 times 10 minus 2 times 5/3. And then I just multiply it out and figure out my maximum volume. Okay? So the dimensions of the box are 5/3 by 5/3 is 1 2/3, so it'd be plus or by 3 1/3 by, this is 10/3, so 10 minus 10/3, 10/3 is 3 1/3, so it'd be 6 2/3. So this would be the dimensions of it. And then you multiply them together to find the volume. Okay, another one. A store is going to fence off an area of the parking lot to display outdoor items. If they want to use 100 feet of fencing, what's the maximum area enclosed if they're going to use the wall of the store as one of the sides, so then they don't have to fence that side? Okay? So they got 100 feet of fencing. Well, if they got 100 feet of fencing, how many W's do I have? 2. 2 W's and 1 L. So W plus 2W plus L equals 100, right? Okay. They want to find the maximum area. How do we find area? Area equals length times width. So what happens here is if I solve this equation for L equals 100 minus 2W. So my area equals 100 minus 2W times W. Distribute 100 W minus 2W squared. That's my area. Now what do? First derivative, 100 minus 4W equals 0. Well, W must equal 25. So if your width is 25 and 25, what's left for your length? 50. There you go. Given a circle, because this is a circle, what's a concavity at this point? How many derivatives am I going to have to take of that? 2 of them. Okay, so 2x plus 2y dy dx equals 0. So 2y dy dx equals negative 2x. So dy dx equals negative x over y because the 2's are going to cancel. Okay, that's first derivative. So let's take the second derivative. So now we're doing the quotient rule. Y times negative 1 minus negative x times dy dx over y squared. Well, what was dy dx? Negative x over y. So it's negative y minus negative x times negative x over y squared. Go plus a positive. So negative y. And then what I'm going to do is get a common denominator up here. So I'm going to go y squared over y. So negative y squared over y minus x squared over y squared. Since I have a complex fraction, I'll multiply by 1 over y squared. So I'll get negative y squared minus x squared over y cubed. So if I stick 3, 4 into there, I get negative 16 minus 9 over y cubed 64. It's going to be a negative over a positive, correct? So I'm going to be concave down there because that's my second derivative. If I want to find my slope, that's the first derivative. Negative x over y is negative 3 over 4. It's going to be decreasing. So that's how you find your slope. And then the concavity is concave down. Where is this function increasing, decreasing, concave up, concave down? Do I need to do another one of those? You did enough of those in Khan Academy. You should be good. If this is the first derivative, where is this concave up? If this is the first derivative, where is this concave up? Wherever it's increasing. Because if it's increasing, the second derivative will be positive. So it's increasing from there to there. It's increasing from there to there. So right there, right there. It's supposed to stay colored in. Okay? That's where it'll be concave up. Where are our points of inflection here? Where the second derivative is 0, except if this goes from positive to positive, it's not really a point of inflection because the concavity doesn't change. Okay? If it goes from positive to negative, then this is a point of inflection. And if it goes from negative to positive, this is a point of inflection, even though it's undefined. Okay? That's a little tricky. So that's why I made sure that one was on there. Hey, that's it. Okay? Now, here we go. Time to vote. Okay? Because this is up to you. Do you want the test split into 2 days? You take a first half one day, the second half the other day, or do you want it all on Tuesday? It's up to you.
How many questions is it?
It is 26 questions.
We have an hour to do 26 questions.
I don't have a class after
2 days.
this,
Yeah,
but other people might.
Other people might. Do you people have bio next after this? Is that okay? So then you don't have a horrible class after a horrible class type of thing. But this isn't a horrible class. This is a great class. Monday would just be a work day
Or test it.
or a half of a test day. Because we're not going to take the whole test on Monday. I'm not going to let that happen.
Would we split it 13-13?
Actually, I have it split 14-12. I don't know why I split it 14-12, but that's how I have it split. Because one other year we ran into this where I think we had forecasted a snow or something like that. So then I split it in half just in case we would have an early out type of thing and we could get it in.
If we have it open, can we stay later?
Yeah, if you have an open, you can stay late. That's not a problem. And if you don't get it done, I mean, you can come in after fourth period and do it too.
Put it to a vote.
Yeah, we will vote, and so how many say split it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many say they want it all on Tuesday? 1, 2, 3, 4, 5, 6, 7, 8. So, no, it's going to be at the same time. It's going to be at the same time. So
Monday's like 10 times worse. Are you gonna like mix up the questions, or is it still gonna be like the first 12 and then the last one?
It's 14-12.
it's 14-12, and I should stop the recording.